Hello, welcome to the second video of this section. This is all on the periodic table and electron configuration, so you are at an advantage because we have already talked about the blocks on the periodic table, so S, P, D, and F, and how those look. You also have an understanding of how to write the electron configuration for various elements. So a lot of advantages here. We are going to focus on labeling the periodic table, different sections of the periodic table. So we watched a video called Hunting the Elements. You learned about some of these elements in detail. Now we're going to focus more on the arrangement and different patterns that are seen among different types of elements. After this video, you should be able to understand the relationship between the number of orbitals in various energy sublevels and the length of the periods in the periodic table. So all I'm saying is that the s orbital contains 2 electrons, so it has 2 elements present in a particular energy level. And I'll explain this more in class in better detail because it doesn't sound like I'm saying it, but I know that when I show you, you'll be like, yeah, that makes sense. Identify each block of the periodic table and be able to determine which block each element belongs to based on its electron configuration. Again, S, P, D, and F. Be able to determine the number of valence electrons for any element. That is a new concept that we will talk about. And then locate the transition elements, lanthanides, actinides, and various other names on the periodic table. All right, so let's go ahead and focus on periods and blocks and what those look like. So there are 7 horizontal rows, also known as periods, on the periodic table. You'll hear me call them periods pretty much all the time. Sometimes I'll say rows, but to be perfectly honest, I confuse the words row and column all the time, and there's really no excuse for it. I just do. Periods and the word periods just makes more sense to me, I guess, in my head. What I really want you to understand is that periods can be determined from its electron configuration. So if you look at the periodic table, again, there are 7 different rows, like I just said it. And each one of those rows is correlated with a principal energy level. So the first row is N equals 1, and that's only made up of 2 electrons, hydrogen and helium. Row 2 has more elements present in it, and it also includes 2 different blocks. It includes the S block and the P block. Row 3, again, S block and P block. And then you move on to period 4, where now we're introducing the idea of the D block. And remember, the D block is always 1 behind the period number. And we'll review that in class. So just a quick reminder on electron configuration. I'm looking at the periodic table and I'm looking at nickel. And nickel has a shorthand expression of Ar 4s2 3d8. Full disclosure, if you were to Google the electron configuration of this, you would probably see the notation as Ar 3d8 4s2. That is another accepted way to write it. I am teaching you the way that I learned in college and the way that is present in my college textbook. So I'm not saying that I am more right or more wrong than anybody else, but this is the way we will learn. We'll learn to read the periodic table from left to right, and I feel like that just makes more sense. If you were to move on, it may change, but you still have that understanding of where they fall on the periodic table and which block you should end with. All right, so let's start talking about the representative elements first. And I gotta move this around. All right, so the S block elements and the P block elements are called the representative or main group elements. And so there's a lot of information here. We really need to talk about a couple of things before we move on to the S block and P block, because I didn't mention them last chapter. You already had so much overwhelming information that we're going to just move on now and start talking about new stuff. And you probably remember the idea of valence electrons. I don't think it's something brand new to you. Now we're just going to use that idea and really relate it to elements on how they look in the lab and when they react with other elements. So the S block consists of elements in groups 1 and 2, and these are primarily composed of highly reactive metals. And group 1 has a special name for it. It's known as the alkali metals, and they have 1 valence electron. Remember, a valence electron are the electrons found in the outermost principal energy level. So for example, if we're looking at lithium, sodium, potassium, rubidium, cesium, and francium, these are all row 1 or excuse me, not row one, group one elements. And then when I'm talking about a group, I'm talking about the columns. So column and group are the same. Those are the columns going down, not across. So group one, all of those elements have one valence electron. It's the outermost energy level. And we will talk about this in more detail in class, I promise. And group two elements are known as the alkaline earth metals, and these have two valence electrons. So the difference between the alkaline metals and the alkaline earth is the fact that alkaline earth metals have two valence electrons. They are reactive, but they're not as reactive as your group one elements. Other special features of alkaline metals, remember that is group one or column one. These are very soft. They can be easily cut with a knife. They are highly reactive with water, so you generally store them in a special place. The reactions between alkaline metals and water are extremely vigorous. This is not something we'll probably do in class, but they also produce high quantities of gases that are not good to breathe in. These are typically not found in nature in their pure and elemental form because of the fact that they are so reactive. So naturally occurring sodium exists as compounds, and more often than not, it is in a compound known as sodium chloride, which you learned is table salt. Elements in group two, so remember that column two, those alkaline earth metals. These elements have two valence electrons, which I have already mentioned. They reside in the outermost s sublevel. So their electron configuration is going to look a little different than the first. They're still too reactive to be in nature by themselves. They're not as reactive, though, as the alkaline metals. They are a little bit harder than your group one, but they have other features that are just a bit different than those in the group one. The next block we're going to focus on is the P block. And the P block includes elements in groups 13 through 18. So in your first video, we talked about the arrangement of the periodic table. And so there are two different ways we can look at the periodic table. You can think of it as like there are two letters. So you'll have your A groups and your B groups, or you can just think of them straight across as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, all the way to 18. And so we are going to look at them as numbers. I just feel like that's a little bit more logical in my head. So groups 13 through 18 make up the P block, and you should already recall the P block. And the P block includes special groups known as the calogens, halogens, and noble gases. Group 16 contains elements that start with oxygen and on down. Group 17, known as the halogens, start with fluorine on down, and the noble gases start with neon on down. And these are special in the fact that they have more than 4 valence electrons. So they have 6, 7, and 8 valence electrons, meaning that they will bond well to something that has an electron to fill them. And we're going to get into a lot more detail on what that means to fill these things in the following chapter. So don't hold on to the ideas of the Lewis dot structures that I'm sure you've learned about in Science 1. We are going to get into a lot more detail on those. So I spent a lot of time talking about the representative elements. Now let's move on to what's known as the transition metals or the transition elements. These are found in groups 3 through 12, that big middle block, that D block. Their valence electron numbers get very tricky because it's not all about the number at the very end. And I'm going to show you this in class. So if you look at lithium, the very last number in the electron configuration represents the number of valence electrons. However, when you start looking at the valence electrons of the transition metals, things can get a little weird because if nickel, we end with 3d8. You cannot have that particular element cannot have 8 electrons. The only elements that have 8 valence electrons are the noble gases. It makes them very special. They are not reactive. They don't bond very well to any other element. So when we look at the transition metals, we really have to focus on a different way in order to determine their valence number or valence electron number. The electron configuration rules are bent for these metals. And so what I mean by that is, remember in the first slide I did mention that you'll see the configuration written just a little bit differently, as in it'll be 3d8, 4s2, and it looks like 4s2 is filled after 3d8, and we know that 8 electrons does not fill our D block. So again, these are just things that are different when it comes to the the transition metals. Electrons in the d sublevel are not counted as valence electrons. So I kind of already mentioned that. Not all of these are reactive, and these metals can be found in nature by themselves. And so one thing that's important to notice is that you have like elements like gold and silver and these high value elements or metals that are found within this group. The only metal that is not solid at room temperature is mercury, and that is noted on the periodic table. If you look, it's like a blue color instead of a black color. That represents the fact that it's a liquid and not a solid. And last but certainly not least, we're going to talk about the F block and the lanthanides and actinide series. So a couple of confusing concepts, because if you look at various periodic tables, there are things that are really, really weird. And so I need to make sure that I am clear. I think I've told you differently 2 times now, and I really do apologize. So please make this clear. Lanthanides are the 14 elements from cerium, which is element number 58, to lutetium, which is element number 71. Those are the 14 elements that represent the lanthanides. So the element La that you would think is associated with the lanthanides is not actually a part of that F block. La, the element La, is a part of the D block. It's the first element in the D block, and I will show you this on the periodic table in class. And the same thing goes for the actinide series. There are 14 elements that start with element 19 and end with element 103. So the element AC is not actually a part of that series. It's like a segue into that series. These are very radioactive elements. They are very much mostly artificially made, as in they are man-made. They are not found in nature by themselves. And so typically these are also called the inner transition elements. So because they are part of the transition elements, but they're not actually in that group, they're known as the inner or like the hidden ones. We will continue to work on electron configuration in class. We will continue to talk about all of the labeling on the periodic table. You will do a coloring activity that involves the groups so that you can get a familiarity with what these groups look like. We will do this in class. We'll talk about all of this. So please, if you're confused, ask me any questions on Edpuzzle. Thanks.